Okay, I figured we'll go over this one more time from class. So just erase this. And like I said before, we're going to use particularly this formula, right, for our points. So these are what we call anchor points. So anchor points. So we're going to build starting from three things. We're going to build it. Log 4x to then log 4x plus 2. And then finally we add on the last log 4x plus 2 plus 5. There you go. So then what we have then is 3 points. Well, we always know that you have 1, 0 is one of them. And just remember, like we talked about above, because you're doing exponents, right? That is simply 1. We can say 4 to the 1 is then 4. And then 4 to the 2 is 16. We care about this value and that one, the exponent and the y. Exponent, which is our x, and 1 is our y, right? Because everything gets flipped around, because as I talked about in here, beginning of class, we have y equals b to the x. Well, that we know goes directly to log. So notice that the base 4, right? Base, in this case, we're going to use 4 for ours. X is equal to y. Well, that's our result. So we know if I put 4 in, I'll get 1. Yeah, I should get 1, right? In that case. So if I put 1 in, I'll get 4, right? If I put 2 for x, I should get 16. Because our base is always 4. So what we have here is, I know then 4, 1. And then the other one would be, it's squared. That would be 2. There you go. So this we know is log just base 4x, right? Then I'm going to go to log 4x plus 2, which is h equal minus 2, right? So then what happens to this? Well, it's going to be shifted over. So that's going to be 1 minus 2. Well, that's just minus 1. 0. Nothing happens to y. What happens to 4, 1? Well, we're going to shift it over 2. Minus 2, 1. What happens to 16? Well, that's just going to go down to 14, 2. There we go. And our final one is log 4 x plus 2 plus 5. So the plus 5 is affecting the y. So it's just right here. That's our k. So we then can say minus 1, 0 plus 5. Well, that's just 5. We take 2 and 1. Well, that's just going to be 2. And we're only adding 5 to the 1. 6. And then the same thing for our last one. This is going to be 14. 5 to add to 2, which is going to give me 7. So there we go. Those are my points. So then I can actually just say this, draw my graph. That's my x. Here's my y range. Right? So that's going to be minus 1. I can call this minus 1, or this is going to be my minus 2. I'll say that, and this is my minus 1. And that's going to be 1, 2, 3, 4, 5. 1, 2, so this is my 5 right here. There's 5. 1, 2, 3, 4, 5. There's 10. 1, 2, 3, 4, 5. That's 15. And then I'm just going to say we're going to go up to just 7. 1, 2, 3, 4, 5, 6, 7. So this will be 7 up here. And there we go, right? So this is going to be minus 2. And we know that h tells us, like I was talking in class, that h is going to be our vertical asymptote. So it's shifted. There we go. So I just added my vertical asymptote. Now I'm going to just put in the points. Minus 1 and 5. 1, 2, 3, 4, 5. There's 1 point. Then I have 2, 1, 2, and then I'm going to go up to 6. And then I have 14 way over here and up to 7. So there's 7. Therefore, I can now draw my graph. It's going to go up like this. It's curves. And there we go. That's how we can do that. There, done. Now I'll do the next one. And we're done. So this is going to work the same way. Log 3x. Well, we know 1, 0 is guaranteed to be there. We know 3, 1 is going to be there. Just think about this. 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, right? You know that this is equal to 3, this is equal to 9, this is equal to 27. 27 is too high, so we could actually just use, we know that's equal to 1. So notice the ones we're using. 1, 0, 1. Or that's the exponent, right? Because this is the exponential, right? That means my horizontal, my log is switched. 3, 1, 9, 2, 27, 3. That's what would be my log. So I know the very next one will be 9, 2. So you can kind of see, already get an idea of this. Then I'm just going to add log. I'm going to do everything close to x first. X plus 3. This is then going to be 1 minus 3. So this is going to go to minus 3. Then I'm going to have this. It's going to be 3. Oops, sorry, because I messed up the y. So this is going to be, 3. This is going to be minus 2, 0, because I'm dealing with the x. This is going to be 3 minus 3, which is 0, 1. And then 9 minus 3, which is 6, 2. And then the last one, I'm just going to have 5 log 3 x plus 3. Remember, a log b x, it's going to be bracket c log h plus k. So, and then what happens is your x, you're going from xy, that's going to go to x over c plus h, and this is going to be a times y plus k. That's our formula, right? If we're just looking at the points. So what you can remember is this is going to be, again, taking this, I have to divide it by 5. So this is going to be 1, or minus 2 divided by 5. Or sorry, whoops. That's y. This is acting on y. This acts on y, not on x. So this is going to be remain minus 2. This is 0 divided by 5. Or sorry, 0 multiplied by 5 because it's my a. So my a here is that one. So my a is multiplied by whatever my y is. So that's just 0. So then this is going to be 0 multiplied by 5. 5 times 1 is 5. 6 stays the same. And then 5 times 2 is just going to be 10. And there we go. Done. So I can actually then plot my final points. Right? So I'm going to just do this. So I need to go to minus 2. So actually it's minus 3. So I'm actually going to put that's going to be minus 3, minus 2, minus 1, and here's my 0. So I'm going to just draw it like that. And then this. So y and x. This is going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There and there, right? So then this is going to be a minus 3. So I know this is my vertical asymptote. because I can tell just by looking at the equation. So reasons I talked about on Friday. Remember, if this were 0, it would be on the y-axis. If this 3 were 0, if that 3 were 0, it would just be the y-axis. But 3 over, that's remember, it's minus 3. Okay, so all I have to do now is just plot these points. So then that's going to be minus 2, 0. So I know it's going to be right here. That's 1 point. Let's use that. There's 1 point. And then it's going to be 0, 5, 1, 2, 3, 4, 5. Actually, I can do this. No, 5. I'll just, yeah, 5. 1, 2, 3, 4, 5. Nah, I'll just keep it the other way. 1, 2, 3, 4, 5. So this will be 5. And then 10. You notice 10, 6. Actually, 6 is going to be over here. And we're up at 10. So this is going to be 5, 6, 7, 8, 9, 10 is right here. So you can see that it's been stretched out. So I'm going to just draw. God, this is hard. So it's going to go something like that. I'd recommend just taking a look at Desmos. But normally, this would be the original. So I'm going to just make the original in blue. Notice what you would have. So this is going to be 1. Yeah, this is going to be 1, 0 is here. 3, 1, 2, 1, 2, 3. And you're up 1 right here. And then you're over at 9 and up 2. So right here. So this is actually what the original looks like. Right? So you can see that how it gets stretched, right? Now, on the next graph, what we see, actually, I'm going to leave that for the next video. So I'll do this one in the next video. And then, of course, the last one. Okay? But it's going to be the same thing over again.